In this video, we're going to talk about expressions and how they can be used. So an algebraic expression represents a calculation to be performed, but it contains variables, and the variables may not be known yet. For example, let's say my washing machine costs $400 and the cost for water and electricity to run a load of laundry in the machine is 75 cents per load. Detergent is about 15 cents per load. My dryer costs $300 and the cost for electricity to dry a load is 45 cents. Okay, so let X represent the number of loads of laundry. The expression for the cost of washing a load of laundry can be written like this. So let's note here that we're talking about washing a load. So for washing a load, you had to use the washing machine. So that costs $400. And then for the water and electricity, it's 75 cents per load. So what they're doing is they're taking the 75 cents and they're multiplying it by X, which is the number of loads. So however many loads we run, they're each 75 cents. So we'll multiply those two together and then add to that the cost of the washing machine itself, which is where that 400 is coming from. So this asks, write an expression for the cost of detergent for X loads of laundry. So if I wanted to throw in the detergent costs there, that would be another 15 cents per load. So 15 cents times X. Now, you can write the times without actually writing the times symbol, just by writing it next to it like that. But you could have also written it with an actual time symbol, like the dot or the X if you wanted. But usually the two X's in a row are a little confusing. Also, so is the dot because of the fact that we have a decimal. So often to make it easier, we just write X right next to the number. Okay. Write an expression for drying loads of laundry. Okay, so drying is different. Drying, we are looking at the cost of the dryer, which is $300, and the drying a load for electricity is another 45 cents. So kind of like the washing one, we're going to take the $300 plus 45 cents times X. So that's how we'd write how much it would be to dry a load as an expression. Oops, I don't need to box the whole thing. Sorry, I'll just box the first one. But you could write it like the second one. The total cost of doing laundry is the sum of the three expressions above. So we added the fixed costs and the three variable costs, and we can simplify this expression. So see what they did? They took the first thing they gave us, which they gave us this. That's this part right here. They added in the second part, which we just did in number 2. And then this last part right here, we just didn't, I'm sorry, we did in number 1 was the 15x, 0.15x. And then number 2, 300 plus 0.45. All right. So they're saying we could simplify this expression if we add the two numbers together. That's the cost of the washer and the dryer. So adding those two together, we'll get $700. And then we can add up all of these costs that are based on the per load. So we have a 75 cents and a 15 cents and a 45 cents. So if we add those together, 0.75 plus 0.15 plus 0.45, which I'm putting in my calculator, I get $135 per load, so times X. So basically, when we're simplifying an expression, we call this combining like terms, meaning we're putting together the things that have similarities. So in this problem, we put together the two numbers that didn't have a variable, and then we put together the numbers that did have a variable. So a couple is dieting. Their expression represents their combined weight after months of dieting, which they're calling M. So let's simplify this expression. So the first person here, they are 175, and the second person here is 220. So I'm going to add those two numbers together. And I get 395. Then we have that one is losing at a rate of 1.5 per month, at 1.5 per month, and the other one is 2 per month. So combining those two numbers together, I'm getting 3.5, but it's a minus because they're both, it's what they're losing every month. Or because I'm adding two negative numbers together, the answer stays negative. And that's how we could simplify that expression. All right, let's look at number 5 then. Let's see if we have some like terms. So I see the number 20, but I don't see any other numbers by themselves without variables. I do see 3 numbers that have X's and 1 that has a Y. Because this has a Y, it is not a like term. It cannot be combined with the others. So all we can do is combine the X terms, and then the 20 and the 6Y can't be combined with anything. By the way, when we don't have a number in front of the variable, we can pretend there is a 1 there. Well, we can assume there's a 1 there and use 1 in place of that number. So here we go. If I do 3x plus 1x plus 5x, that's 3x plus 1x is 4, plus 5 is 9. So I have 9x, and then I still have the 20 that I couldn't combine, and the 6y, which I just left at the front and the back. It doesn't really matter the order, but that I just kind of tried to keep it in the same order and just ended up combining the middle 3 into 9x. Attending a movie costs $7 per person. Popcorn costs $2 per person. What is the total cost for X friends to attend a movie? Assuming all of them are buying popcorn, I think. So they want us to simplify the expression 7x, that's 7 for each person, plus $2 for popcorn for each person. We can combine these two variables together since they are like terms, and that's going to give us $9 per person. Let's come up with an expression for the cost of a term at LCC. LCC is a school in Oregon, Lane Community College. The cost of tuition is $113.50 per credit in 2018. There's a $9 credit technology fee, and other fees come out to $128.05 per term. Let X be the number of credits a student is taking. Let's write an expression for the cost of tuition and fees for a single term and then simplify. So let's start with the tuition. They're going to pay $113.50 per credit. So since they said X is the number of credits, we'll times that number by X. Then there's a class that has a $9 credit fee, or maybe that's all of the classes have a credit fee, meaning in order to use their like technology labs and stuff. And then there's other fees they're going to pay that approximates to be $128.05 per term. But since that's per term, and this is just for one term, we only need to put one term there, and that's it. So we can combine some like terms. In other words, we can combine the 9 and the 128.05 since they don't have variables. So that's going to give me 113.50x plus, so adding 9 is 137.05. So that's how much they'll spend for that single term. Okay, now they are going to introduce a new concept. Let's say we want to have 3 terms. So I'm going to multiply that expression I just created by 3, as you can see there. But what that does is it introduces a concept called distribution. We can distribute the 3 to each term. So what they're doing is they're taking this 3 here and they are multiplying it by the first term and the second term. That's what they're indicating right here. 3 times 122.5 and 3 times 128.05. I just realized that the $9 fee, just based on my answer versus their answer, I assumed that wrong. So here, I actually am going to fix that. You should fix it too, unless you caught it, which good for you. So it's actually $9 per credit. I just realized that. Okay. So since it's per credit, oops, sorry, let me use the same color. That's 9x plus the 128.05. Okay, so actually, in this case, we can combine the X terms, which is going to be 122.50x and then the 128.50. Well, isn't that nifty that they wrote that down there so I could catch that mistake? And if you saw that, good for you. And I'm sorry if that confused you. Oops, 05, not 50, 05. All right. Coming back down here, if we use the 3 terms, they're distributing the 3, and as you can see, they multiply 3 times 122.50 and 3 times 128.05, which comes out to, if you grab your calculator, 3 times 122.50 is 367.5. 3 times 128.05 is this 384.15. So these are giving, those multiplications are giving us those numbers. So they want us to use the distributive property ourselves. Let's try it. So they're asking us to do 30 times what's in this parentheses. So I'm going to multiply 30 times this and 30 times that. So if I want to write it out, 30 times 113.50x plus 30 times 16. So I'm going to grab my calculator and do 30 times 113.50, and I get 3,405x plus 30 times 16, which comes out to 480. So that's what I get for number 8. And here I'm going to zoom in a little. It seems a little far away. Sorry. Okay, so here we're going to distribute 48. This one's a little bit easier. I'm not going to show the multiplication because 48 times 1, that's just 48. And 48 times r is just 48r because I can't actually do any multiplying. So that's that. A waiter brings you a bill that comes to $48. You're going to pay $48 plus a tip amount. If you tip 20%, what will the total come to? Use any method to work this out. So since we've done percents before, we'll go ahead and take 20% of 48. So that means we're going to do change the 20% to decimal. So 0.20, moving the decimal twice, boop, and times that by 48. And that's going to give me what 20% of it is. So we do that on my calculator. I get 9.6. So that means I'm going to tip 960. So the total in the end, I'm going to add that to the $48. And I get $57.60 is what I'm going to spend. Now they want to show us there's another way I could have thought of it. I could have used what's called the distributive property and thought of it as 1 being what I'm going to spend on the meal, plus the 20%, the 100% for the meal, and then 20% for the tip. So in other words, in this meal, I'm spending 120%. So we could have wrote it as the distributive property. So we can always calculate a tip by using 1.20. In other words, they're just taking 48 and multiplying it by 1.20. That's representing the 100% is the amount you're going to pay for the meal plus 20% on top of that. That's where those numbers are coming from. So let's use the same method to find the tip. If your total came out to $28 and you want to tip 15%. So that means I'm going to pay the 100% plus an additional 15%. So 1.15. That is what I'm going to multiply by 28. And I'm going to grab my calculator and plug it in. And I got 32.20. So here's another way the distributive property comes in handy. Let's say we want to multiply 5 by 43, but we don't have a calculator. We could rewrite 43 as two things that are much easier to multiply 5 by. 5 times 40, that's way easier because 5 times 4 is 20 plus an extra 0, so that's 200. 5 times 3 is 15, and adding those two together is 215. So let's use that technique to do these multiplications. So instead of 7 times 32, I'm going to do 7 times 30 plus 2. So 7 times 30, or 7 times 3 is 21 plus a 0, so 210. That's the 7 times 3. And then 7 times 2 is 14, which gives me 224 when I add those together. No calculator. Okay. Now, there's a couple options for the one below, but I think they actually wanted us to do the 9 instead of the 14. So there's a couple of things I could do. I could just swap the order of the 9 and the 14, or I could just rewrite, sorry, I'm going to cough here, 9 as, oh no, I take it back. I think we could do the same trick. I think we can do the same trick. I think we just take 9 and do 10 plus 4. Yeah, I don't know what I was thinking. I don't know why I wanted to make that more complicated. This is not too complicated. Okay, 9 times 10, that's 90. 9 times 4, that's 36. Oops. And 90 plus 36 is 126. Let's use the distributive property to rewrite this expression. So we're going to take 1,000 and times it by 1, which is just 1,000. And then 1,000 times 0.06. Now, you can grab your calculator to do that, or technically, whenever you're multiplying a decimal by tens and multiples of tens like this, like 10 to the third power, sorry, I should have said powers of 10, 10 to the third power, you could move the decimal. But grab your calculator if you're not sure, do 1,000 times 0.06, and you're going to come up with 60. And since there's a t, 60t. And there we go.